Hello everyone, my name is Afikile Sikwebu. I will be presenting a paper titled Starting from Scratch, Introducing Primary School Learners to Programming. This paper was co-authored by Professor Darrell van Grienen of the Nelson Mandela University in South Africa. Developing countries have not yet taken full advantage of the technological advances that could potentially address the needs of poor societies. As a result, learners into rural township schools are often not exposed to ICTs and they consequently become late adopters of technology. This is against the backdrop of a technology-driven world where information lives in the cloud and is constantly raining at our fingertips. The motivation of this research is the introduction of coding in primary schools in 2020, as announced by the Department of Basic Education in South Africa. In this research, we wanted to explore the use of Scratch as a tool to introduce coding to learners in under-resourced primary schools. And secondly, we wanted to determine a method of teaching Scratch that is appropriate for learners in similar backgrounds. In order to conduct this research, the following approach was applied. A single case study of an under-resourced primary school was done. We designed 24 lessons, which lasted for 1 hour for each lesson in 1 week. And the lessons that we conducted, they lasted 24 hours of coding, or they equated to 24 hours of coding rather. The research population comprised of 156 learners with 70 boys and 86 girls of the ages 12 and 13 and in grades 6 and 7. The school is in a community with gang violence, in a community where there is high school dropout. The school has very limited resources in terms of the computers in the school and sporting facilities, and there's no computer teacher, and the internet connectivity is limited to the administrative block and can only be used by the teachers, and there's no internet connectivity in the computer lab. In this section, I'm going to discuss the observations and findings during the duration of this research project. We discovered that some of the learners have a limited ability to work independently. We saw that some learners would rather work as a team of two. This we observed especially in the classes which had fewer computers than the learners. There are learners which always almost preferred to sit together, and even at times when there were open spaces, they would not want to be separated. So, and also in observing their projects, we saw that they did not naturally explore the artifacts, but instead they waited to be told what to do. This was also true in the lessons where we allowed them to conceive their own projects. And one of the things that became a concern during this research was that the learners, they did not want to do anything without being told. And this became evident to us quite early in the lessons. And we realized that the teachers discouraged the learners from touching the computer unless they were told to touch. And even when we looked around the walls, there were posters that discouraged the learners from touching the computer equipment. And we felt that this was counterproductive because we wanted the learners to explore on their own. And so we had to get them to a place where they knew they could touch without breaking anything. And We also felt that, or discovered that, we have to start from scratch. We have to start from the very basics, and we cannot assume digital fluency in any of the learners. And we therefore started teaching them how to use the mouse, teaching them how to use the keyboard, teaching them how to turn on and turn and shut down the computer. And this not only got the learners comfortable in using the computer system, but it also eased some of the anxieties that they have over the computer and their space. At this stage, the learners are told in order to discover. And secondly, the learners need to see how the code affects their artifacts or their sprites in the interface. And therefore, they must be allowed to try different coding blocks on their own. And in this stage, they need to see in order to try. And then finally, when the learners are comfortable with the interface and how the coding blocks function, they must be allowed to explore their own ideas, to develop creatively and iterate their learning. And at this stage, they learn, they discover, and then they create with technology. They also discovered that we must always expect unintended consequences. And unintended consequences are defined as the product of an action within a particular process, and they are not the actual outcomes of that process. And it is true that undesired effects are not always undesirable effects. In this research, for instance, one of the learners discovered Encarta, the encyclopedia, and while they were using this encyclopedia, they discovered that they could do their school work in it, and more learners started seeing this encyclopedia, and they started talking about it. And all of a sudden, all of the kids now wanted to use this encyclopedia, and they started coming during the break time to ask if they could use the computer lab to do their research for their projects using the encyclopedia. So, unintended consequences do not always yield undesired effects. And while the study was limited to investigating the use of Scratch in teaching primary school learners to code, the question of the computer's role in the learner's life and what they want to do with it needs to be interrogated, because sometimes we have our preconceived ideas of what learners must do with computers, but we also need to know what they want to do with it. And finally, we need to create and leave room for exploration. Our initial lessons centered around using Scratch to code, but some learners discovered they could record voice clips, which sparked an interest. This prompted us rather to allow those learners that finished the lessons early to use this function to record. And we discovered that they started singing into the microphone, they started recording themselves singing, and they started uh, using the code to control their voices uh, in a limited sense. They started coding their voices. This opened up a room for the A in STEAM, or rather the A in STEM, which is the arts component. In this section, I'm going to address the issue of challenges that we experienced during this research project. The first challenge was the issue of language. We had composite classes rather, of isiXhosa, Afrikaans, and English learners. And we found that whereas the lessons were conducted in English, we had to use the most basic form of English to make sure that nothing was misinterpreted in the long run, as it was the case that when we started the lessons, I had tried to explain an algorithm, and I used the phrase a series of steps. And the teacher called me during the lesson to explain to me that some of the learners were confused about what I was talking about because they could not see the stairs that I was talking about. So they took the word that I had used, stairs, steps, and they had changed it in their minds to visualize a staircase. So we had to make sure that we always use very simple English to make sure that everyone was in one page. And the learners also were very dependent, and they lacked the confidence to try out new things on their own, and they relied heavily on being told. And as this case demonstrated, the learners under observation, they relied heavily on the facilitator being the bearer of knowledge, while they were the consumers of knowledge. Uh, the third thing is that we had limited computers. We had 22 computers, and we had in excess of 27 learners in some classes. And so uh, this became a constraint together with time, because we had to now pair some learners. Um, we then had to make sure that there were always in a team there was a strong learner, to make sure that one was the driver and the other was the navigator. And as a result of this, we had to take extra time to make sure that we explain things uh, in ways that they both the team members could understand. And and we also know that some of the learners only interacted with the computer for that 1 hour in the week, and that was all that they had. And they could not therefore practice after we had left, and they also could not practice at home because they do not have computer equipment. And then finally, the lack of teacher development. The teachers are not receiving training in digital technologies for teaching and learning. And while we would love to train teachers at the school that we were at, some of the teachers mentioned that they just do not have the time in which to do it because of the workload that they have. And so um, their development is hampered in that regard. In conclusion, the learners showed a positive attitude and were keen to learn while they experienced difficulties in using the tool. Scratch somehow proved too advanced as an introductory tool to these learners. While the concepts in Scratch can help learners academically, especially in mathematics, this needs to be taught in their earlier grades. Some learners preferred to work independently. Some preferred to work as a team. Some learners preferred to be instructed on exactly what to do, always, while others wanted to see the code projected to them, while others wanted to work on their own individually conceived projects. Teaching learners to code is a challenge that needs innovative ways, particularly in this era of the fourth industrial revolution. And Scratch is one of those ways. Thank you very much for listening to my presentation. I will now take questions that follow.